Okay, kids, you're going to get full measure today. We're going to talk about synthetic division, which is a special subset of long division. We can only do it when we are dividing by a linear factor. So if we are dividing a polynomial by x plus or minus some constant. Here's a linear binomial. We can do this. If we were trying to divide by x squared, we could not use synthetic division. All right. Here, I'm going to do long division first, just to remind ourselves what long division looks like, and believe me, you are going to appreciate synthetic division because it has quite a few reductions in the number of pitfalls. What I see as pitfalls here in long division are when you are subtracting. Anytime students are subtracting polynomials, they're very apt sooner or later to get into trouble with subtracting a minus or something like that. Now remember, our goal when we're doing long division, that's what we're doing here, long division of polynomials. We're going to talk about synthetic in just a moment. This is a little review. You can skip over it if you like. X plus 1. So if we think back to the definition of synthetic division, dividing by a linear factor. And what do we have here? A linear factor. I know that because my variable is to the first power and no higher. I am going to try and get rid of this by matching it and then subtracting. So that would be x cubed. Now please notice where I'm placing it. Right over the x cubed column. X cubed times x gives me x to the fourth, and that's what I want to do. I want to match to that. Plus x to the third. Now what do? I subtract that. And when I do, this becomes 0, and this becomes 3x cubed. I bring down the next term. My goal again is to get rid of the first term here. So I'm going to have to multiply x by, that's right, 3x squared, a positive 3x squared. When I do so, I get 3x cubed and a positive 3x squared. Now I'm going to subtract that to give me the 0 I wanted, and here I'll have 3x squared. I'm going to pull down the next, which is a positive 4x. My multiplier of x to get to 3x squared must be plus 3x. That'll give me positive 3x squared and a positive 3x, which I am going to subtract. Now this will 0, and this will be just plain old x, 1x. I bring down my next and final term, and I see that this will work with 1. So I'll have x plus 1, which I'm going to subtract, leaving me with a remainder of 0. So that happened to divide in evenly, a remainder of 0. So it could be written as being factored, right? X plus 1 was a factor. of this larger polynomial. When I factored it, I had this left. I'm going to talk more about factoring and using either long division or synthetic division to test for whether something has a factor or not. All right, so a little review. Now let's get into the good stuff. Synthetic division. The quotient is the answer that you get after you divide something called the dividend. See it right here? This is the dividend. Take something called the dividend and you divide it by the divisor. Here's my divisor. The quotient will include the remainder. It'll be plus whatever that remainder is over the divisor. Oh, I guess we got it. All right. If the divisor is linear, a polynomial such as x minus something, then you may use synthetic division. So we're going to look at these divisors and determine whether or not we could use those in synthetic division. Or would we have to use long division? How about this one? There is a problem here, isn't there? This has a 1 in front of it. There's nothing about a multiplier on it. So we wouldn't use synthetic division for this. Could we use? Yes, here we could. Yes. This one? Yes. This one? No. And this one? No. Please notice that when we talk about synthetic division, we always think of it as x minus something. So in this case, it'll be x minus a positive 14. And this one we would think of as x minus a negative 3. That's going to become important in just a moment. This method that we're calling synthetic division is limited to linear divisors where the coefficient of x is 1. An x plus 1 is the same as x minus a negative 1. And since we have to have it in the form where it's x minus something, what we're going to use as our divisor is that negative 1. Now the thing that is beautiful about this, we don't have to write down any of the x's. We do have to know where they are though. If I'm doing this problem, which has x to the 5th, x to the 4th, 3rd, 2nd, 1st, and x to the 0, then I'm going to make sure I have all those columns in sequence. But I only write down, I think this is such a neat way to do things. I didn't learn this when I was in high school. If they had invented it, they just didn't share it with me. I would have loved it. So there's the 3. There's the negative 1. There's the negative 2. Here's a positive 1, right? We know we don't see the 1 written, but it's there, right? A negative 6 and a negative 7. So we've written them down in the proper column, and we have written the divisor we're going to use. We're not going to even write the x. We're going to use a negative 1 for this divisor. Now, the first thing we're going to do is we're going to bring down the leading coefficient. We can't get started until we do that. So you don't have to do any calculations at all, you simply bring it down. Now we can begin the calculations. The first thing we do is we multiply this by a -1, which gives us what? A -3. We place that product in the next column. Now this is why I like synthetic division. We add. We don't have to worry about subtracting like we did back here. We kept having to subtract. Adding, I believe, is a little more straightforward, so consequently I like synthetic division. Also, you don't have to write all these x's out, so it seems quicker too. We're going to add these together, and that will give us a -4. Now we multiply again, and we're multiplying I think I better get that out of the way because it's confusing. We're multiplying a -1 times a -4. That's right. It'll give us a +4. Now we add. Gives us a +2. Multiply. -2. Add. -1. Multiply. +1. Add. -5. Multiply. +5. And add -2. So what does this all mean? Now, I had x to the 5th in this column, but when I went down here, I dropped one power of x. Why is that? Because I just divided everything by x to the 1st power. So your powers drop by 1. And if I go to write this out, it's going to look like this. 3x to the 4th minus 4x to the 3rd plus 2x to the 2nd minus x, right, that's x to the 1st, 1x to the 1st, minus 5. Of course, that's x to the 0, but we know that's the same as 1. With a remainder of -2. And if I write that as part of my quotient, it looks like that. Synthetic division. We're going to go through many examples. Does this one fit as a divisor? Remember, it has to have this form, x minus a. It does. And in this case, my a is going to be equal to, that's right, a +5. I'll try writing it out. X minus a +5. It's either got to be positive or negative. In this case, it's positive. So I'm going to put that +5 right here. Remember how I start my process. I'm going to pull down my leading coefficient. Well, I better write them in, hadn't I? Get my coefficients written. I've got a +2, a -7, -11, and -20. So a +2, a -7, a -11, and a -20. I've placed them in descending power order, just like they are written in standard polynomial form. I bring down my leading coefficient, which is a +2, and I multiply that by 5, which gives me 10. Now I add, gives me a positive 3. Multiply, positive 15. Add, okay, a positive 4. Multiply, I have a positive 20, so I get a remainder of 0. I love it when I get a remainder of 0. Now notice I dropped from a polynomial in the third power to a polynomial in the second. That's because, although I only wrote the 5, we know I was dividing by x minus 5, so I dropped 1 power. My answer here, my quotient, is 2x squared plus 3x plus 4 with no remainder. That's my quotient. It went in evenly, so I can think of it as being factored, can't I? When it goes in evenly, I know that x minus 5 was a factor. We'll try another one. I'm going to mark the coefficients that I'm interested in. And I'm going to examine my divisor. X minus what would equal x plus 2? That's right. So for synthetic division, I'm just going to put the negative 2 here. Now I'm going to put these coefficients in. I've got a positive 2. I've got a positive 5, a positive 5, and a positive 6. Remember, we start the process once we've got our numbers written in. We start the process by bringing down our leading coefficient, 2. Multiply it by the divisor, negative 4. Add, multiply, add, multiply. Ooh, another one that I like so well, a remainder of 0. My quotient here becomes 2x squared plus 1x, so I'll just write plain old x, plus 3x to the 0, I'll just write plus 3. I know because my remainder is 0 that this was a factor, went in evenly, x plus 2. Another one. I've got 2 as a coefficient. I've got 30 minus 2 minus 1. Those are my coefficients. And let's check this out. I know I have to be in the form of x minus a, and a is going to be my divisor. So I'm dividing by a positive 4. Now there is a new wrinkle here because I've got 4, 2, 1, 0, skipping the power of 3. I'm going to put a placeholder in here for the power of 3. I know I don't have it, but I'm going to put something in. You can imagine what I'm going to put in, can't you? I know that my leading coefficient has to be a plus 2. Skipping over this for a moment. Then in my x squared, I've got negative 30, negative 2, negative 1. What would you put here? We could put plus or minus, but since I favor pluses, put plus 0. Just to remind myself that I have to pay attention to this column. I start by pulling down my leading coefficient. Now I'm ready to do my calculations. 4 times 2. Add 4 times 8. Add 4 times 2. Add 4 times 6. Add. Oh, my nice streak of no remainders has changed now. This time I have a remainder. X minus 4 is clearly not a factor of this polynomial. However, it doesn't change the fact that I now know what the quotient is. See how important it was for me to have this column here? I wouldn't have gotten the right answer if I'd neglected it. Plus a remainder of 23, which I can write as a fraction, 23 over my divisor. Okay, synthetic division, when I had to have a placeholder for a missing power. It's going to happen again here too, isn't it? I'm still missing a power. I should have 4, 3, 2, 1, 0. So I'm going to hold that place, and you know what I'm going to do. It's going to be a plus 0. What about this? X minus, is my 3 positive or negative? That's right, it's positive. Now I'm going to put in the coefficients that I do have. What's the coefficient of this one? That's right, it's 1. This coefficient on the x squared term, there we have them all. We'll bring down, now we'll start our calculations, or get ready to. We bring down that leading coefficient. Nothing starts until you get that leading coefficient in place. Now, we're starting that cycle of multiply, put your product here, add, put your sum here. Multiply, product, sum, product, sum, product, sum. Okay, we'll go through it. 3. Now we'll find the sum, the product, the sum, the product, the sum, the product. Yes, this I like. The remainder of 0. This tells me that my quotient is a factor, and this was a factor of the dividend. All right, so I've got 1x cubed plus 3x squared minus 1x minus 1. And I could write that as factors because it did go in evenly. How would you set up this as the dividend for synthetic division? Well, let's dash backwards and make sure we know what the parts of a division problem are called. The dividend is what you're dividing into. All right? So how have we been setting up the dividend? Well, we look at what is our highest power, right? And then we go down 1 power at a time. So when we set this up, we say, all right, right here we're going to have a plus 5. Maybe I put the plus on there, maybe I don't. I don't have anything for x squared, so I'm going to put in a plus 0. For the first power, I'm going to put in a negative 2. And for the 0 power, I'm going to put in plus 5. So that's how that would be set up. Of course, I would do this. And I would prime everything by just pulling this down, wouldn't I? Then I'd multiply by whatever I would get for my divisor. So suppose this were the divisor. How do you write that? We always have to think of it as x minus a. And it's going to be a that you put there. So that'll be x minus, now is 4 going to be positive or negative? That's right. So when you set this one up with a divisor in synthetic division, you're going to write it as a negative 4. I've been asked to do a few more I shouldn't say that, a few more difficult problems. Nothing negative about it. So here's one. I don't know if you'll think this is more difficult or not, but I think it's a little challenging. Our divisor is a negative 1, isn't it? Well, let's put that in place. And we've got all the powers here, so I don't have to worry about placeholders. I'm just going to put in the coefficients. And they're all positive 1s. Well, maybe that's not difficult enough. Seems like maybe that's simple. I'm going to pull the first one down. Now I'm ready to start my calculations. You remember how the calculations go? Product, sum, product, sum. Okay, we'll get started. Product, sum, product, sum. Actually, it is a little tricky, isn't it? Product, sum, product, sum, product, sum. I love it. I always feel so satisfied when I get a remainder of 0. Oh, but what do I have for quotient? I've got 1 x to the 4th. I have no x to the 3rds. I have 1 x to the 2nd, no x to the 1st, and 1 x to the 0, which is simply the number. So this one turns out that x plus 1 was a factor of this polynomial. Well, I know the numbers weren't difficult, but you did have to stay on your toes about where you had zeros. So that's a little bit tricky. Now, this one, well, let's look at the divisor first, because we know what to do with that. We want it in that form, so it's going to be x minus, it's got to be a negative 3, doesn't it? So we're going to put a negative 3 there. And the highest power is a 2, so I've got x to the 2 here. I suppose I could write it out. You don't have to, by the way. I'm doing it for instructional purposes, but there's no need for you to do that when you do synthetic division. It's just one of the things I like about synthetic division is you don't have to write the x's. So there's no reason why you have to write those out. Now my leading coefficient here is 1. And then what do I have? I need a placeholder. So I'm going to say plus 0. And then I've got a plus 3. Now I'm going to erase these. We know what they are. I don't think I need to be writing them down. Okay. What do we do first? We can't do any calculations until we bring down a leading coefficient. Now we're ready to multiply. Then we add. Then we multiply. And then we add. Now we have to think about, we went from x squared to x. So this is simply 1x. This is x to the 0, so minus 3x to the 0 is just minus 3. Then this, in our last column, is our remainder. Okay, so don't get tricked on that. So it'd be plus 12 over our divisor, what we were dividing by. Beautiful. Oh, done. I think I gave you a couple tricky ones. Not necessarily really long ones, but ones that would make you think a little bit. We'll see you back in class.